So I welcome you all and thanks a lot for listening in. I'm very excited to talk about this brand new technology we just released in September. So it's the REAlease Releasable Antibodies. And I hope you like it and you see something interesting today. So shortly the outline, what I will talk about today. So first I would like to explain a bit better how this technology actually works. Then I will show you some performance and application data, talk a little bit about the features and the benefits of the REAlease technology, and of course also information about the product itself, how you can order and how you can find even more information on our website. So let's get started. The REAlease technology, the principle. How does it actually work? So the REAlease releasable antibodies relies on recombinantly engineered antibody fragments. So it's not a full-length antibody we're talking about, it's an antibody fragment and it's recombinantly engineered. So why is this so important? When we look at antibody binding to its target epitope on a cell, we always talk about a stable labeling of cells. And this is due to the multivalent nature of the antibody. Since it has two arms and therefore can bind two epitopes at a time, it's a very strong binding to the cell. When we talk about antibody fragments, as you can see here down below, we're missing these two arms, so it's a monomeric antibody fragment and therefore has a low affinity. So therefore the binding to the cell is rather unstable and leads to dissociation. But this fact we used and we created what we call the REAlease Fluorochrome Complex. So what we did is we used our antibody fragments, as I just said, and coupled it to a backbone, and to this backbone we coupled the fluorochrome. Therefore we create or engineered or mimic, let's say, an antibody or the nature of an antibody, and therefore resulting into a stable binding to the cell. So when we want to release it, we simply add what we call the REAlease release reagent, and what it does is it destroys the backbone of this complex. Therefore, our antibody fragments get monomerized again, so they fall off the cell simply. And this results in not only fluorescent label-free cells, if you want to call it like that, but also to completely label-free cells. So there is no fluorescent dye attached to the cell anymore, and also the antibody is gone, which leaves you with label-free cells. All epitopes are available again for staining. So what is this REAlease technology for? So it's designed for cell sorting, and I would like to show you let's say the workflow, how you would use the REAlease releasable antibodies. So first, as you used to when you start your flow sorting experiment, you just simply label your cells with the REAlease antibodies, like you would do with conventional antibodies. Next, you will perform the sort as you used to. You just sort your target cells out, which then will end up in a tube, for example, or in a plate, however your setting is or looks like. And then you simply add into your tube the REAlease releasable reagent. You have to incubate it for 15 minutes. The backbone will be destroyed and the antibody or the antibody fragments fall off your cell, which leaves you with label-free cells at the end, which you can then use for further downstream application. So this means this technology gives you the full flexibility after your sort to do whatever you want with your cells. So you could either perform a second flow sort, for example, with the REAlease conjugates. So if you're looking for a really minor subset where you need a lot of markers to characterize the cell and to sort it out, you could go for a second flow sort, since you have all the channels available again, so you can use all the colors. Or you simply do whatever you would do after your flow sorting, functional assays, or you relabel again for simply analysis, because since you have all the channels available again. Or you could also think of microscopy experiments on the downstream end. So as I said, you just simply have the full flexibility to do whatever you want with your cells since they are label-free now. So let's give you some examples and also some details about the performance of those REAlease releasable antibodies. So first I would like to show you that you don't lose any performance like you used to with conventional antibodies. So here's an example. We used the REAlease CD4 antibodies in 5 different colors. So you see here the Vio blue, the Vio green, the FITC, PE, and the APC. And the CD4 stain is on this direction, and it's counterstained with CD3, as you can see on this axis here. And you see a nice positive population when you stain with your REAlease antibody. So when you compare this now to conventional staining, so we used here our affinity CD4 conventional antibodies, you can see when you compare the left to the right that you don't lose any quality in your staining. So the staining performance of the REAlease antibodies is equivalent to conventional antibodies with comparable brightness and low non-specific binding. So you don't have to worry that you will lose any signals, frequencies, or you miss cells when you use the REAlease technology. Also, I told you that since we revised the multimerization, so the antibody fragments fall off the cells, you will end up with label-free cells. But of course I have to prove that to you, because you will just not only believe it because I tell you so. So again, you see here the 5 colors, Vio blue, Vio green, FITC, PE, APC, and it's again a CD4 staining as an example, counterstained with CD3. And this is stained with the REAlease. Then we added the REAlease release reagent to the staining, and you see that all signal is gone. For the Vio blue, the Vio green, the FITC, the PE, APC, doesn't matter which color you use, which conjugate you use, the staining is gone. Compared to a negative control where there's no staining at all, you see it looks very similar. And then we relabeled again with the REAlease Fluorochrome. And why did we do that? So to prove to you that it's not only the fluorescence or the color is gone, you can't detect the color anymore, but it's actually the epitope which comes available again, proving that the epitope is also free of antibody, so to speak. So we restained with the REAlease the same epitope. So summary, the removal of REAlease antibodies is highly efficient and selective with no detectable fluorescent signal remaining after the release step. And the labeling efficiency in the relabeling step is equivalent to the initial staining, demonstrating that epitopes become completely available again. So now you probably ask yourself, how do we do this destroying of the backbone I talked earlier about? And this is an enzymatic reaction, so we use an enzyme to destroy the backbone. Therefore, of course, the first question from your side will probably be, but what happens then to my cells? Are they still happy? Are they viable? Is there any loss in function? Are my epitopes still preserved on the surface? So therefore, we performed some experiments to look into this. And this is like one example. So we checked cell viability here. And so we used negative control without any treatment. And then we used the enzyme in 10 minutes, like we recommend to use it in your experiment. But then we also tried the double incubation time, like 20 minutes, the double enzyme concentration for 10 minutes, and the double enzyme concentration and the double incubation time, so to speak. And we compared it to a positive control where we were simply using DMSO. And as you can see, so we checked it on 3 different donors. There is no effect on cell viability at all when using, or so to say, treating your cells with the REAlease Release reagent. Also, we checked for cell surface epitope preservation. So how did we do that? So in the Miltenyi portfolio, there is another product called the Max Marker Screen. And with this product, you can screen over 300 different surface markers at a time. So we used this one. So we used again all these conditions as we used for the cell viability assay, and then analyzed it with the Max Marker Screen plates for all the surface markers which are on those plates. And also here, we didn't see any changes or effects on the epitopes tested. So up to now I only showed you basically single stainings, but since we are talking about flow sorting, this is not really interesting, because with flow sorting we're talking about multi-parameter, multi-color stainings. And is it also working then in a, for example, 5-parameter, 5-color staining panel? So here is an example of a T-Reg panel where we used CD3, CD4, CD25, CD127 and CD45RA in one panel. And this is all performed with the REAlease antibodies, as you always can see in this picture. So in the first row is like simply you see the labeling and the different gating strategies following here. And then on the row down below, you see the stainings after the release. So we simply added again the REAlease Release reagent, and then we analyzed it again on a flow cytometer. And as you can see here, all colors and therefore also all labels are gone again. So it simply works also with more colors at a time, more antibodies at a time, the same way as it would be working in a single staining. And I would also like to show you an application example, so to speak. So we performed a sort on our Max Quantido sorter, and is again the T-Reg panel but only using REAlease CD25. All the other markers in the panel are conventional antibodies. And so we used the CD25 APC REAlease Releasable Antibody. And as you can see here, this is simply the staining, so the labeling. It's first gated on lymphocytes and then gated on CD4. Then we performed the flow sorting, and you see the negative fraction non-target cells on the left, and on the right the sorted fraction target cells. And here's again the staining, so the CD4 against the CD25 REAlease, and then further gated on the CD25 CD127, and this is, as I said, the negative fraction. And here on the right you see the sort of the CD25 positive T-Reg cells. And on the next step, so we released again using the REAlease Release reagent, so the CD25 falls off, and this is what you can see here. And then we relabeled again the sorted fractions to prove that we really sorted for T-Regs with FOXP3. And the FOXP3 we used the APC channel again, which was available again since we released the CD25 APC, and stained against CD25PE, which also shows nicely again that really the epitope was available again, so you could restain with CD25 in a different color, and at the same time could use the APC channel again since you released the CD25 APC and this channel became available again. So what are the features and the benefits of this technology? So as I said, it's designed for flow sorting, and it's also designed for multi-parameter fluorescent sorting, because the big advantage, of course, of flow sorting is that you can use a lot of markers at the same time if you would compare it to magnetic isolation of cells. And then you would perform your flow sorting, as I said, and then afterwards you can release the fluorescent label as well as the antibody label. So you're ending up with label-free cells. So this means that the epitope of a marker becomes available again for staining or even restaining of the same epitope. The fluorescent channel becomes available again for whatever kind of analysis you would like to do afterwards. It's a key for clinical and preclinical applications since your cells are label-free. And it's interesting, of course, for specific downstream applications down the road after the flow sorting, because the flow sorting is just a tool to get the cells you want, and then most likely the interesting experiments starting with the downstream applications. And as I mentioned in the very beginning, it's a recombinant technology. This means it's very reproducible, so it gives you standardizations in your assays. It's lot-to-lot consistency, and it's even animal component-free, which could be very interesting for GMP applications at the end. So what are the benefits? So as I said, since you get label-free cells at the end, you have the full flexibility of your cells again for the downstream applications, which is the interesting part after flow sorting. So you could even think of multiple cycles of sorting. If you're going into like a deep subset, for example, with dendritic cells, this could be a very interesting tool. And of course, if you would want to reanalyze your cells after you sort, either with flow again, or you could also think of microscopy, since you now have all your fluorescent channels available again. So for microscopy, this could be very interesting, since you have the freedom to choose whatever dye combination you want. And also you could think of, after sorting, that there is no need for expansion of your cells anymore to get rid of the antibody labeling, since you now just add the REAlease release reagent, have to wait 15 minutes max, and then you have your label-free cells. So no hassle of expanding your cells over a couple of days to get rid of the antibody. This could also, in fact, be interesting for adaptive transfer experiments. If you would think you sort, for example, T-Rex cells, and you would like to inject them back into a mouse and see the effects in regards of different disease models you're looking into. And also for molecular and genetic analysis, it's practical to have label-free cells at the end, and also for cell cultivation and cell function assays after the sort. And so all you have to do, as I mentioned now already a couple of times, is to add this REAlease release reagent after you sort. And this release, as I also showed you already, is highly efficient. It's fast, since it's not taking longer than maximum 15 minutes. The temperature range is like in the same range you would work anyways. And it's cell-friendly, non-toxic, as I showed you, so since the cell viability is not affected at all. So therefore, I actually would like to address some questions to you, and also hoping to get some feedback from your end, what your thoughts are when you're doing your experiments. So I was wondering if you have asked yourself if all these antibodies might have an effect on your assay experiment setup. So when you do perform a flow sort and you are planning a downstream application, have you ever thought, the antibody on the cells is actually a hassle for me? Or maybe only the fluorochrome, since it could have toxic effects on my cells. Or that you were thinking maybe the antibody affects my cell growth after sorting, and that's why a lot of times they are dying. Or if it's possible to stain the cells again with different markers afterwards. So, and what would it mean to you now, since you heard now this would all be possible, so you could stain your cells, sort them, and remove the antibodies altogether? So where would it help your research? And so this is not only just asking you a question like this and you're like, yeah, whatever, she will move on. So I'm really asking you, where would it help your research? And I would really like to have your opinion and get some ideas what kind of experiments you are doing, and where this technology would make your life easier. So I open up the chat now to you to give me some feedback. So I'm getting different questions, not only regarding where would it help you, the REAlease technology, but I will just like answer what comes in. So I got one question, why not using tandem dyes, since I showed you on the slides these 5 colors, bio blue, bio green, FITC, PE, APC. The answer is actually you can do it with tandem dyes, and the tandem dyes will come. So they're not available now, but at the beginning of next year we will have them. So we will have the PE Vio 7770, which is the equal of PE size 7, and we will also have APC Vio 770, which is the same as APC size 7. So it's working with tandem dyes the same way. And I got another question asking, how do you stain in multi-step for multicolor experiments, e.g. for 5 antigens? 5 steps or other way around? I don't know if I understand the question correctly, but it actually works in the same way as you would stain with normal antibodies. So you just prepare your panel, your master mix in a tube, and then you just add it to your cells. So it's all in once. You can just combine them all together. You don't have to add one antibody, wait, and then the next one, the next one. You can do it just all in once, and that's the same is true for the REAlease. So there is no problem. It's the same as you used to with normal antibodies. And also, and now I see the addition, I mean the REAlease technology only. So if you would combine, if you have a panel where you would only use one REAlease releasable antibody in it and the rest is just normal conventional antibodies, you can just also put them all together in one mix. It doesn't matter. You don't have to pipette it separately in or something like this. So then I have another question saying, I would love to be able to sort T-Rex cells that secrete IL-10 for functional assays and delabel them. Are you planning to combine this technology into your secretion assay kits? Well, that's an interesting question. So far the answer is no. But it is actually an interesting idea, I have to admit. So far we were like also only focusing on surface markers anyways, so therefore we are not looking into cytokine FABs or whatever, even though I know this is not an intracellular assay, it's like catching the cell while secreting. So I will keep that in mind, but at the moment this is not planned to combine these two technologies. And then there's another question, which is referring to if we also have the REAlease technology or the REAlease antibodies for microbeads. And the answer is yes. We already have this product available on the market since almost a year. There we have limited specificity, so to say, but we do have them. You can look it up on our website. And it works in the same way. It's a bit different because it's not a direct label. So it goes first via biotin, but at the end you can also release the whole complex from the cells. And then I have another question asking which other functional features did you check after enzymatic digestion, like proliferation or other functionalities? So here, so far, we don't have a lot of additional data, I have to say. I have a lot of beta testers at the moment as well who tried out the REAlease for me, and there I will get data like this back. I did check, so I do have data available for phosphor signaling antibody staining after sort and release compared with conventional antibody sort, and there I also see no effect on the signaling pathways. So this data I have, and there will be more data proving that the functionality is not affected by the REAlease. And then I have another question asking, is REAlease technology applicable for clinical trials for adaptive transfer? Is it already clinical grade approved? So at the moment the answer is no. I mean, I told you it's a recombinant technology, so that means everything is animal component free, that's for sure. Also the REAlease reagents, or recombinantly engineered, or yeah. So, but we don't have it in a GMP grade yet. But this will also come in the future. So for sure, we will have it in the future. So then I have another question coming in. Which antigens do you have REAlease antibodies for? Actually, there will also be some more slides going a bit into this topic, and I will also provide on one of my last slides the website link where you could go directly there and check it out. But I can tell you that there's already quite a lot of antigens available. So if there are no more questions for now, I will just go on, and then we also have time probably at the end. So regarding the product information. So I would like to give you some insights how we filled this pipeline and how we came up with the specificities we have available as of today. So we focused, so our first priority was the immunology section, so to speak, since Miltenyi Biotech is an immunology company. So the first focus was on T cells as well as on B cells, and also I have to say on NK cells. And then on a second round, we will release also markers for the stem cell area, as well as for the dendritic cells, I have to say, since there we had some difficulties in developing it, but they will all come. But so on the first round, we released mostly markers targeting the T cell area, the B cell area, also monocytes we have available. And so you're happy to go on our website to check out if there's something you are interested in. And so how can you order it? So as I also mentioned already earlier, we launched this whole portfolio in September this year. So it's really brand new, fresh, out there for you to try. And since I told you that you basically need your REAlease antibody, of course, to stain, but then you also need the REAlease release reagent to release, you need to order 2 products. So first of all, as I said, the REAlease releasable antibodies. So here I just have a simple example to make it a bit easier, the REAlease CD5 APC, for example. And then you would also need to order the REAlease support kit, we call it. So and in this kit, you will find the REAlease reagent, and also in case you would like to relabel with the REAlease again, you would also need a relabel reagent, which you will find in this kit as well. Also, it's not out just yet, but it will come the 1st of December, so quite soon. We will have a kit variant available as well, where you can buy all in one. So you can choose for your REAlease antibody of choice. Here as an example again, the CD5 APC. And then in this kit, there will also be the REAlease support kit included, where the REAlease release reagent is in and relabeling. So in summary, just to give you the most important messages I wanted to give you today. So the REAlease Fluorochrome Technology relies on recombinantly engineered antibody fragments and not full-length antibodies, very important. The REAlease releasable antibodies are designed for flow sorting and further downstream applications. The features of these technologies are at the end that you will end up with label-free cells, and it's all recombinantly engineered. And the benefits is, of course, that you have all the flexibility in the world after your flow sorting to for your downstream application, in case you do believe or you do think that maybe having the antibody still attached might change the outcome of your assay. So I provide here the link to our website where you can read also more about this technology. There's a brochure available as a PDF on the website. There's also a poster available on the website with some additional data and information. And of course, you can see all the products we have available already. With this, I say nothing anymore. I just say let's get started. Go on the website, see what we have, try it out, and I hope you do have a benefit of, or you can find your own benefit of label-free cells at the end. So thanks a lot for listening, and of course I'm open for more questions.